Welcome back to another episode of Who Wants to Be a Mathematician? I'm your host, Mr. Hill. We're going to be jumping right back into it. So, families of graphs, day 1, exciting. We're going to be on example 2, so we're at page number 4. We're going to be doing letter A. I'm going to be describing transformations, then we're going to sketch the graph. So, here we go. A, g of x is equal to x minus 2 squared plus 3. Oh my gosh, Mr. Hill, g of x, I'm so confused. What does g of x mean? Well, we used to have y equals, then we upgraded to f equals, now we're upgrading to g equals. All it is just another name. We could have h equals for Mr. Hill. We could have t equals for the very awesome Mr. Hill. So if we have different graphs, we have like x squared, x cubed, x to the 4th, x to the 5th. Instead of saying, oh, it's the x to the 5th graph, and it has more things like 2x plus 3, instead of saying, oh, the graph that's x to the 5th plus 2x plus 3, we could just say the t of x graph, or we could just say the g of x graph. So it's just naming our functions, f of x, g of x, h of x, t of x, y. They're all just names for different functions. So, g of x is equal to our x minus 2 squared plus 3. So step 1, find the parent graph. What are you? Where are you? If we take away all our numbers, so we just take them away, right? They're gone. We're just left with our parent graph. And what's that? Oh, that's simply our g of x is equal to x squared. Done. But now those numbers aren't gone. We actually have to listen to them. So plus 3. Alright, so if we graph our parent graph, what do we look like? Well, x squared, pretty simple parabola. We're going up on the right and going up on the left. You could think of it throwing up the horns. We're just throwing up the horns for this parabola. And now, step 2, we're going to find shifts. That's not really a 2, there we go. We're going to find shifts. So, if our g of x is equal to our quantity x minus 2 squared. If attached to our x, if the number is attached to our x, we know it's a horizontal shift. And it's going to do opposite of what we think. So if we think negative 2, it does opposite and goes right 2. So 1, 2 goes to the right 2. And if we add on, so x minus 2 squared, to our quantity of x, if we add on 3, that's going to be our vertical shift. And how many are we going? We're going up 3, positive 3 in the up direction. 1, 2, 3. So our new starting point is at 2, 3. We've gone right 2, we've gone up 3, and we're now here. And what does it look like? It just looks like our parent graph. So our g of x equals this. We start by knowing what our parent graph looks like, then we shift it, so it's just our parent graph shifted. That's all. So there, A is done. Now we're going to move on to B. No, I'm going to have you guys do the left-hand side. I'll do the right-hand side. No, reverse that. I'm going to do the left-hand side, and you guys are going to do the right-hand side. So I'm going to go on to C, E, and G, and then on your own you do B, D, F, and H, and we'll converge at the end. So here's what it looks like. C, g of x is equal to 1 plus 1/2 square root of x plus 4. What's step 1? Parent. Find the parent. Here we go, parent graph. After we take away all of the numbers, they're gone, and we're just left with our variables. G of x is equal to the square root of x. So all the numbers are gone, we're just left with the square root of x. And now we have to graph our parent, because that's going to tell us what our graph is going to look like. So our parent graph, we know the square root of x starts at our origin and shoots off to the right. Shoots off. Done. Parent. So now let's start looking at our shifts. G of x is equal to, start off simple, x plus 4. If the number is attached to our x value, we know it's a horizontal shift. If it's a horizontal shift, we know it does opposite. So if we're thinking positive 4, it goes to the left in 4. So 1, 2, 3, 4. Nice. So now we have g of x. And we're multiplying this thing by a half. And if we remember, if we multiply by a number less than 1, what happens to it? Does it get steeper or wider or shallower? So 1/2 is less than 1. So that means we're getting shallower or less steep. So the next and last step is we're adding 1 to the quantity that is our x plus 4 square rooted times 1/2. So if we're adding it to a quantity, we know it's going to be our vertical shift. And what is it shifting? It's a positive 1, so we're going up 1. Up 1. So our new starting point is to the left. Oh, that didn't make sense. Why did I write that? Left 4. That's so weird. So we're shifting it to the left 4. We've gone up 1, and we know it's going to be shallower or less steep. So here we go. Left 4, up 1. Less steep kind of looks more flat. And that's what it is. So our g of x is equal to this. We look at our parent graph, we draw our parent graph, and we draw our shifts. Good. That one's done. Let's move on to